All right, so in this video, I'm going to continue our discussion from the previous lecture, including ending with two problems, one of which we sort of partly went over. So let me sort of summarize the ideas for vectors. The first thing that we talked about in vector is that each point in space x comma y comma z is associated with a vector that is an arrow which is pointing from the origin to this point x, y, z. Representation, there's two ways of representing it. One is using angular brackets, and what this really means is this is x I cap plus y j cap plus z k cap, where recall that these are simply the unit vectors in each direction. The second thing that we looked at is if you have 2 points, right? If you have x1, y1, z1, and another point P, which is x2, y2, z2, then the vector pointing from A to B, this vector AB, is x2 minus x1, y2 minus y1, and z2 minus z1, or its equivalent notation using the I, j, and k cap. Okay, so now let me go to this problem over here. Usually for vectors, what we do is one of the ways of using these components is that we break everything down into either the x direction or the y direction or the z direction and balance things out. So let me actually copy this whole thing and just start from scratch with this. Okay. Before I do that, let me just go over one of the sections called components of a vector, because there were some questions about how we got the sine theta and cosine theta. So in two dimension, let's take any vector that goes from one point A to a point B. Let's call this vector V. It has some angle that it makes. This angle is theta. Now, you can think of the x component as what happens if I project this down to the x-axis. So basically, we are talking about this side. And we talk about the y component as what happens if I flatten this vector in the vertical direction. And then it becomes this arrow on the y-axis, which is called the y component. But if you look at it carefully, these are just these two sides of the right angle triangle. And so by using trigonometry, we have using SOHCAHTOA, right? So you have sine, which is opposite. So you can think of it as the vertical arrow divided by the vector, right? The vertical being the y component. Whereas cosine theta being SOHCAHTOA is adjacent over hypotenuse, and the adjacent in this case is your x component. So that gives us this relation, which is that your x component, or at least the magnitude of it, is going to be the magnitude of this cosine theta, and the y component is going to be the magnitude of v sine theta. So that's all there is. That's basically, you're looking at two different shadows of the same vector. So how do we apply that here? Well, we look at this situation, and we make this the origin. We draw this rectangular grid and we are in 2-dimension. Now if this is 32 degrees, this angle is going to be 32 degrees. And if this is 50 degrees, this angle is also going to be 50 degrees because these lines are parallel. When you have two parallel lines, then these opposite angles are always the same. Okay, so what we have in this figure, if I redraw it here, is one vector pointing at 32 degrees, another vector pointing at 51 degrees, and we do not know their values. So what we do is we find its x component for both of these. So this will be t1 cosine 51 and this will be t2 cosine 52. And we do the same for the vertical. So if I project it vertically, I will have a t1 sine 51. And if I project this vertically, I will have a t2 sine 32. And opposing all of these is at the bottom, there is a force of 100, which is the weight of your block. So we get two equations here. First of all, vertically, because the object is not moving, the t1 sine 51 degrees plus the t2 sine 32 degrees should add up to 100. And horizontally, for the same reason, that is that the block is stationary, t1 cosine 51 degree minus t2 cosine, this should be 32 degrees, should equal 0. And now from here you can solve for t1 t2 by elimination. And what's that? That's what you've learned in earlier classes, because remember, these are just numbers which you can find using the calculator. Right? So you can use elimination or substitution. Okay, I will not go all the way, but if you take this equation, you get t1 is t2 cosine 32 divided by cosine 51, which you can plug back into the first equation to get t2 cosine 32. So this you can replace by a number, right? This will be a fraction, times sine 51 plus t2 sine 32 equals 100. So now you have an equation in the same variable, right? So you can factor this t2 out, equals 100, and t2 is 100 divided by whatever the complex looking expression here is. Okay, let's look at a second problem here. So in this case, a woman launches a boat from the south shore of a straight river, and just by reading it once, you know it's a problem of swimming in directions. Okay, so let's say north and south side. So we have this being the east and this being the west. So the river is flowing to the west at 4 miles an hour. And let's suppose she starts here and she wants to land at a point directly across on the opposite shore. So wants to land here. The speed of the boat relative to the water is 8 miles per hour. What does this relative to the water mean? It means that when it is sailing, that's what the speed of the water is. So it's if there was nothing going on, then it would be going at 8 miles an hour. So we've seen this in the poll question from the last lecture, is if you go straight, it's going to end up here. And if you overshoot in this direction, or somewhere this direction, well, let's not take overshoot because that doesn't really concern us. But if you sail straight, you're going to end up at the red spot. So to end up here, you're going to have to sail somewhere here so that eventually you end up here. So our goal is to find out where this should be. Okay, so effectively, what this is asking you is to find an angle, right? So it's trying to find this angle theta. So we will do the same thing, which is set up an axis. We know one of the arrows is exactly horizontal, right? That's the speed of the, let's call this VC for current. So that's the current. This current VC is -4 I cap. It has no J component because it's completely horizontal. And then we have the speed of this boat is at some angle, right? Some angle theta. So V boat theta, which means its x component is VB cosine theta. Actually, we know what the speed is. It's 8. And its horizontal component is sine theta j cap. Now what do we want? We want that when we add these vectors, the velocity of the current and the velocity of the boat, to point to the north. So it should be pointing straight above, which means it is a vector with no I cap component. That's what it means, right? So basically what we want is, we want VC plus VB to have no I cap component. But what is VC plus VB? It's -4 I cap plus 8 cosine theta I cap plus 8 sine theta j cap. So it is -4 plus 8 cosine theta I cap plus 8 sine theta j cap. Now what do we want? We want this to be 0. So all we have to do is solve, find the value of theta, and this goes back to Math 140, where you learn how to solve trigonometric equations, which is 1/2. So one of the answers, I'm just going to use the first quadrant result here, is going to be pi over 3 or 60 degrees. So if you sail at 60 degrees, in this particular scenario, you will sort of reach where you want, right? Exactly opposite. And if you think about it, it will always be the ratio of your current speed and your boat speed. So inverse cosine of that will give you the angle in which you can always release yourself so that you reach exactly on the opposite end. Okay, so that was the problem that did not have time to discuss in the lecture. And yeah, so hopefully you'll also take a look at the material on dot product and cross product. Okay, that's it for this one.